So this diagram explains policy-based routing, policy-based redirect setup in a Cisco ACI environment. It shows how traffic is routed through a service node, for example, a firewall or a load balancer, using a service graph between Client EPG and a Web EPG. Let's break it down. Key components here: logical configuration, top right, showing you the Client EPG, which is the consumer, represents the group of clients or endpoints initiating traffic. Web EPG represents the group of web servers or applications hosting services. And then the contract. Contract governs the allowed communication between the Client EPG and the Web EPG. The service graph is applied to this contract. The service graph contains the PBR node, which redirects the traffic through the service node. Physical configuration: we have the client leaf on the left, connected to the Client EPG. The subnet is 192.168.1.0/24 and is associated with the client bridge domain. The service node leaf that's in the middle hosts the service node. This is the firewall or the load balancer. Traffic is redirected here via policy-based redirect. Two bridge domains are configured. The Svc-external bridge domain is the external facing connected to the client, and Svc-internal bridge domain, this is internal facing and connecting to the provider. So the provider leaf on the right here connect to the Web EPG. The subnet is 192.168.2.0/24 and is associated with the Web EPG. From a traffic flow perspective, a client in the Client EPG, for example, client with IP address 192.168.1.1, initiates traffic to a server in the Web EPG. The web server is IP address 192.168.2.1. This traffic matches the contract between the Client EPG and the Web EPG. Due to the service graph applied to the contract, the traffic is redirected to the policy-based redirect node for inspection and processing. Traffic first enters the Svc-external bridge domain on the service node leaf. The data plane learning is disabled on this side for the service node bridge domain to ensure the proper traffic forwarding without unnecessary MAC address learning. Traffic is processed by the service node, inspected or manipulated by the firewall. Traffic is forwarded to the Web EPG. After processing the traffic is forwarded from the Svc-internal bridge domain to the Web EPG, to the Web bridge domain on the provider leaf. The destination server receives the traffic, and the return traffic follows the same path in reverse, going through the service node again before reaching the Client EPG. The key bridge domain configuration: client bridge domain on the consumer side. The IP subnet is 192.168.1.0/24. Default gateway is the leaf, 192.168.1.254. And the purpose is the leaf acts as the entry point for the client traffic. Svc-external bridge domain is the external side of the service node. The IP subnet is 172.168.1.0/24. Disable data plane learning is special configuration that you need to have that prevents the bridge domain from learning MAC addresses dynamically, ensuring traffic is explicitly forwarded to the service node. Service internal bridge domain, the internal side of service node. The IP subnet is 172.16.2.0. Same configuration to disable data plane learning. Why disable the data plane learning? Disabling data plane learning is because on the service external bridge domain and service internal bridge domain, this ensures that traffic always flows through the service node as intended. MAC learning does not interfere. MAC learning does not interfere with the redirection, avoiding unintended direct communication between endpoints. As a summary, traffic between the client EPG and the web EPG is redirected through the service node using a policy-based redirect and a service graph. Two bridge domains exist: service external and service internal. Isolates the traffic, isolate the service node, external and internal. Disabling data plane learning ensures consistent and predictable traffic flow.